All right, boys. First time doing this problem, by the way. I tried to record this video like 3 times, but it is what it is. This is 118 Pascal's triangle. This one's not too bad. So given a non-negative integer num rows, generate the first num rows of Pascal's triangle. So what we're doing here, we're going to have to return, we're getting an integer which has num rows, indicating the number of rows. So if we look at our input here, we have 5. We get 5 rows we have to output. So in Pascal's triangle, each number is the sum of the 2 numbers directly above it. So if we take a look here, if we're trying to calculate 2, 2 is the sum of 1 and 2. 3 is the sum of 1 and 2. 3 is the sum of 2 and 1. 4 is the sum of 1 and 3. 6 is 3 and 3. 3 plus 3 equals 6. And so on. So what we have to do here, another thing to note is that Pascal's triangle, all the first items, or all the left side of the triangle is going to be 1. All the right side of the triangle is going to be 1 as well. So one cool thing, or an easier way to think about it, we have to return a list of lists, right? And it seems complicated to generate these ones, but it's actually not that complicated. So if you think about this as a list of lists, it's just the first item and the last item in every list is going to be 1. So if you know how big your list is, which you should if you're making a list, you can just do capacity minus 1 to get the last item in the list and set that to 1. And then you can do list sub 0, set that to 1, to set both values to 1. Another important thing to note is that for each row, we're actually going to have row items in the list. So for the first row, we're going to have 1 item. For the second row, we're going to have 2 items. For the third row, we'll have 3 items, and so on and so forth. That's really important to note. The fourth thing is in Pascal's triangle, each number is the sum of the 2 numbers directly above it, and they literally mean directly above it. So an easier way to look at this in terms of lists, because if you look at it like this, it seems really complicated. But if you look at this as a list of lists, like down here, or up here actually, if we wanted to create 2 here, which is a sum of 1 and 2, 2 is the second item in the third list, right? So if you take the second item, which is index 1 of the second list, so index 1 of this list is 1. And then if you subtract 1 from that index, you get indexes 0 plus 1 of the previous list equals 2. And this, you can extrapolate this all the way down to the bottom. So the fourth item in this list is going to be 0, 1, 2, 3. And it's going to be created, so if we take the fourth item in the previous list, 0, 1, 2, 3, the third index, minus 1, add these 2 together, and you get the fourth item. So it's really not too bad if you think about it as a list of lists. If you try to think about it, if you try to structure the problem how you see it here, it's going to get really complicated really fast. So to start, what we can do is just create a list triangle, right? So that's that. And then we have to iterate for each number of row times. But we don't want to iterate through the list and be like, oh, well, the first row is actually going to be row 0, and the second row is going to be row 1, the third row is going to be row 2. That's too complicated. We want the numbers to match up correctly just because it's going to be much easier. So what we can do is do for row num in range, we're going to start from 1 here and go to num rows plus 1. This way we can go from 1, 2, 3, 4, 5 if we're working on this list over here. Let me just check I'm still recording. Okay, I am. We're going to add a colon here, and what we're going to do is we're going to create a list. Our list is just going to, we're just going to create a list of all zeros, right? And so the syntax here is just going to say, create a list of row num items. So create a list, so we're going to do a row element, a list of one element of 0 times row num times, put it in a list and return it. So we're going to get, if row num is equal to 5 here, we get a list with 5 elements. They all have zeros in it. This is equivalent to something like this, except we're not hard coding it. Or in some languages, you can do something like this. You can specify the size and a default value. So 6 elements, all set to 0. So that's pretty much what we're doing here. And then, like we said, we have to make this Pascal's triangle, right? So that if we thought about this as a list of lists, the first item is always 1, and the last item in the list is always 1. We know the length of our list, it's row num items long. So the first item is going to be set to 0, and we're going to do row num minus 1 is going to be set to 1. Might be thinking, well, won't we go out of bounds if we're making the first list or the second list? Well, let's walk through it. So if we're making the first row num is going to be 1 because we're starting at 1. Row underscore list sub 0 is going to be equal to 1, true. And we're going to start with a list that has only one item available in it. Now row sub row num minus 1, and we said row num was 1. 1 minus 1 is 0 equal 1. So we're just setting it to 1 twice here. The second row is the first row that you get where you actually set the values to different. We'll be working with different indexes. And then once you get to the third row, you'll have spaces in between where you'll have nothing in it but zeros, right? So now we kind of created Pascal's triangle here with just these lines. I mean, we didn't add it to the list or anything, but technically we have. We'll just have a list of lists and they'll all be set to 0 with the first and the last item set to 1. Now we have to calculate the stuff in between, right? So the second way we can do that is we can do for index. So we want to iterate for the indexes within each list. For index in range of 0 to num rows minus 1. Why are we stopping minus 1? Oops, my bad. We're going to start at 1 because we want to only work within the range, right? We already set the first item to 1 and the last item to 1. So we're going to start at 1 to skip the first item, and we're going to go minus 1 to skip the last item. Then from here, what we can do is just use what we said earlier. We said that if we want to set, since we're only iterating between the values in here, we said to set the value, right? That if we wanted to calculate 2, it was literally the same index. It was a summation of the sum of the same index in the previous list minus 1, right? How do we get those values here, right? So this might make a little more sense if I do this right here. So I'm going to append the row list now at the end of the for loop so that it makes more sense. So what we're going to do is we're going to say triangle, right? Because this is going to be our list of lists, triangle sub index minus 2. I mean, not index, oops, row num, right? So let's say we wanted to calculate 2 here. Our row number is 3, right? We want to get to the second list here, right? So we say row num minus 1, right? And we get 2. But that's not how lists work, right? The second index in the list is 1. So we have to actually say minus 2 to get to the second index of the list. So it might be easier if we look at it like this. These are the indexes of the list. If we're at the third list, which is here, and we say, oh, minus 1, right? We'll say, oh, get the second index in triangle. Well, there is no second index in triangle, right? Because the loop didn't finish yet and we didn't add it in. So we have to do minus 2 to actually get the second list, right? So now that we're in the second list, we said it was the summation of the same index of the number we wanted to calculate. We wanted to calculate 2, which is in the second index of this list. Second index of a list is going to be 1, right? So this is going to take us here. So we can actually just do index here. So now we have the first one, right? We need to add it to the first one in the list. So we're going to do plus triangle sub row num minus 2 sub index minus 1. Thus adding these two numbers together, and when you get further down the list, these two numbers and these two numbers and these two numbers. And that should be that. That'll calculate the values that are in between. Then after we're done, we'll add the row list that we made to the triangle, right? Let me delete this stuff here, and at the end of the function, we'll return triangle. And this should work. Oops, index out of range. Oops, oh my god, not num rows. This is going to be row num. Oh, list index out of range. What is going on? Row num. Oh, yeah, okay. I think we had a... Alright. I'm a 3-head. I just figured out what the problem is. Okay, all the code is fine. I forgot to indent. We want to add the list once we're done. I just forgot to press tab, I guess. But once this list is done, right, we create all the values in between that we wanted to create. Like let's just say here, we have to actually do triangle.append row list in the same loop, of course, to add it to the triangle. What we were doing before is adding it after everything had finished. So this list will only ever have 2 lists in it. That's not how that's supposed to work. That was my bad. And so you see, we're doing pretty good here. It's pretty fast. So this first time doing this problem, by the way. So what's the time and the space complexity, right? Be easier to explain if we take a look at here. So we have to iterate for num row times, right? Because we have to create num rows, right? So we have num rows, which is 5, and we have to iterate, each time to create 5 rows, right? So we have to iterate at least 5 times, the first time. But we have to create, num row elements for each num row iteration. You can see that here for row num in range num rows, and then we have to iterate for each index in row num, right? So the time complexity there is actually going to be num rows squared, right? Because for each row num, we have to iterate num row times, right? And that's kind of unavoidable. There are probably faster ways to do it, but for this way, that's kind of how we're doing it. So space complexity is kind of easy, right? So if we said we're running in num row squared time, each time in the loop, we're storing a value, right? So our space complexity is going to be the same. Our space complexity here is going to be num rows squared, right? Because each time we're storing a value in num row squared time, each time we're iterating through, we're storing a value. So in this algorithm specifically, they're tied pretty closely. So we're going to have num rows squared time complexity and num rows squared space complexity. So that is Pascal's triangle.